Alright, so yesterday we learned how to pack up an expression and factor it back into sets of parentheses. Hopefully you realize that although the steps we use to factor seemed a bit random, they actually make it decently easy. Let's look at a couple examples to ensure that we still remember the process. First off, keep in mind that you are going to be handing these notes in to me at the end of the day for credit. Also, the work that you do on MathXL later, because you are working independently for the most part, and by independent I mean working together with the other students, with Mr. Nazo, you actually do get extra credit for the questions that you answer, so that'll go in as a quiz. That'll boost your grade a little bit because of the hard work you've been doing. So again, answer as many as you can. If you finish, you probably get something really, really good, but other than that, like I said, just get as much as you can done and make sure you get that far. Anyway, looking at the examples, remember that we are looking for numbers here that multiply to be negative 24 and add to be positive 13, or just 13. So we make the tree for 24. 1 times 24, 2 times 12, 3 times 8. No, I'm wrong. That's 48. Anyway, multiplies to be 48. Let me start over from that. And adds to be 13. So 1 times 48, 2 times 24, 3 times, I think, 16, 4 times 12, 5 no, 6 no, 7, no, 6 does go times 8. And so looking at that, what we have here is, again, the fact that it makes a negative 48, remember, means the signs are different. The fact that it makes a positive 13 means my big numbers are positive. And because the signs are different, that the numbers look like this. The ones that are 13 apart in this case are negative 3 and 16. So again, that's what we worked on last week. And what we learned yesterday was we take just this portion of the number and we put it into two fractions. So 6x over negative 3, also 6x over 16, and we reduce those fractions. So we do. And I'm not going to use the negative because there's no need. I'm just going to do 6 divided by 3, which gives me the answer of 2. And remember what that means, that this is a fraction, so it's got to be 2 over 1. And so again, I'm going to put a 2 over, and again, the negative was there, is going to stay there. So remember, it turns into 2x over negative 1. I am then going to do the same thing with 6x and 16. So 6 divided by 16 gives me the fraction 3/8. So this is going to be 3x over 8. And remember, in the end, we turn this into two factors, 2x minus 1 and 3x plus 8. Again, notice I didn't need the negative here because once I got the answer of 2, I knew it was just 2 over 1, and the negative was going to stay negative. If that 16 would have been negative, then this would have been a negative 8. So again, as you get used to that, some of those things kind of get easier for you. So just kind of keep that in mind. B, here we're looking for numbers that multiply to be a regular 20 and add to be negative 9. And so we make our tree for 20 as 1 times 20, 2 times 10, and 4 times 5. The fact that it makes a positive 20 means the signs are the same. The fact that it makes a negative 9 means that everything should be negative. And so you end up with your numbers being negative 4 and negative 5. Here, the only thing that we can put a square around whenever it's got the x squared is just the x, because again, remember, we ignore the squared in that situation whenever we do it. So we simply put x over negative 4, and we put x over negative 5. There's no way to reduce those, and so you end up with x minus 4 and x minus 5. So again, just a real quick review to make sure we see it, and make sure you write all this down, because again, in terms of your notes, if you want that participation and the extra credit, I need to see that your notes are completely done, and then I go to MathXL to see how many questions you got right, and then I put that in the book for you at the end of the day. Here we're looking for numbers that multiply to be negative 30 and add to be, remember, if there's no number, negative 1. And so the numbers for 30 are 1 times 30, 2 times 15, 3 times 10, 4 doesn't go, 5 does with 6. The fact that it makes a negative 30 means the signs are different. The fact that it makes a negative 1 means that my big side should be negative and my small side should be positive, because again, the signs are different. The ones that make a negative 1 are 5 and negative 6. So again, what we do here is we ignore the squared, look only at the 2x, and we put that into two fractions. So 2x over 5 and 2x over negative 6. 2 over 5 I don't think reduces, but you can always check that out. 2 divided by 5, math, enter, gives me 2/5. So yep, that's just 2x over 5. 2x over negative 6, again, I'm not going to use the negative, I'm just going to do 2 divided by 6 and see that it gives me the fraction 1/3. And keep in mind that since there is a negative under there, that the negative will stay. So remember, we don't need the 1, but you can put it for the sake of your own understanding. But like I said, usually I scratch that out. And so you end up with 2x plus 5 and x minus 3. Today what we are going to do is apply this concept to problems in which we must factor out the GCF first. Remember that if a problem is factored correctly, we can distribute it back to get its original answer. Consider the answer from the problem in the problem B that we just factored above. X squared minus 9x plus 20 factored out to be x minus 4 times x minus 5. Well, if we distribute that, you should notice that you get x squared minus 5x minus 4x plus 20. When you put those two things together, you get x squared minus 9x plus 20, which means that this and this match. So again, if you notice, our answer from distributing this actually led us back to our original problem. So let's check that situation out with this problem here, just to kind of show you what our challenge is of the day. Today you're looking at numbers like this, and it's going to say multiply as to be 48, as to be 14. Again, 48 is 1 times 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Because it makes a positive 48, it means that the signs are the same, and since it's positive, everything is positive. The numbers that make 14, I'll just tell you, are 6 and 8. Taking those numbers and coming back over here and ignoring the squared, you get 4x over 6 and you get 4x over 8. Reducing those fractions, again, 4 over 6 gives you 2/3, and 4 over 8 gives you 1/2. So again, 1x over 2, which we scribble out the 1. That ends up being 2x plus 3 and x plus 2. So we did our proper work. We know that everything works. We know that that answer is what we would consider to be the right answer. But as it says here, distribute to see if the answer matches. Let's look at that real fast. We have 2x plus 3 and x plus 2. And when you multiply that, you end up with 2x squared plus 4x plus 3x plus 6. This gives you 2x squared plus 7x plus 6. And that is not the same as our original problem. But if you look carefully, 4 turned into a 2, 14 turned into a 7, 12 turned into a 6. So really everything here, if multiplied by the value of 2, would match. And that, again, is our problem. That's the biggest challenge that we have right there. So again, notice that the answer is different from the original, and that's because the values of A, B, and C in our original 4, 14, and 12 all could be divided by 2 because they're all even, which is why in the end you would actually be able to do something different to your answer and have to do that to make it right. No matter what method of factoring you use, I don't care who your teacher is and what they teach you and what they say the factoring rule is, you have to make sure you understand that if you fail to check for a GCF before you factor, you run the risk of making a silly mistake. So because of this, our number one rule is, and you might want to highlight this and make sure you always use this, is to always check for a GCF. Now let's look at how it works before you get some time for practice. So looking at this problem here, here's the first hint. These numbers are huge, and I really don't want to try to find two numbers that multiply to be 4,116, because that would be a huge factor tree. So what I kind of do here is I cross my fingers and I look at the lowest number here, 21, and I think, okay, 3 goes into 21, so let me see if 3 goes into 133. No, it doesn't. But 7 goes into 21, so let me see if 133 goes into 7. It does. Let's see if 196 goes into 7, or 7 goes into 196, and it does. So therefore what that means is that before I get started, I can actually take out a 7 and then turn this into 21 divided by 7 is 3x squared. 133 divided by 7 was 19, so plus 19x. And then 196 divided by 7 turned into 28. And that makes it a much nicer problem to deal with. And now I am simply factoring this part. So I'm looking now for numbers that multiply to be whatever 3 times 28 is, which is 84. And yes, it's a big number, but it's not nearly as big as what it was, and adds to be 19. So I go and make my tree for 84. 2 and 20, no, 42 is 1, 3 and 28, 4 and I think 21, 5, 6 and 14, 7 and 12, 8, nope, 9, and notice that my answer is the same, which means I can quit. Looking for the ones that make 19, we end up with 7x and 12. And so since we're factoring this, we go into this portion of our problem to get what we need. And so again, we keep our 7, but we're going to go ahead and do the answers first. So 3x over 7 is 1, and then 3x over 12 is the other one. Checking for 3x over 7, it does not reduce, but 3x over 12 does reduce. That'll be 3 over 12. Math, enter, enter. Again, the factoring is still the same. 1x over 4. The difference is, since there was a 7 out here, we now have to leave that 7 out there and then put our 3x plus 7 and our x plus 4. So again, your answer here is the same as what you did yesterday, but whatever number you took out has to stay in front of that parentheses for you to do the rest of it. Alright? Looking at the very last one for this lesson here, factor 15x squared minus 50x plus minus 40. Again, these numbers are big. I really don't want to try to multiply 15 and 40 because that's a big number, so I'm going to kind of cross my fingers and see if there's something that goes into all three. I notice all of them end in a 5 or 0, so that means you can at least take a 5 out. So 5 would lead to 3x squared minus 10x minus 8. And now since this is much more simple, I can now factor this to look for numbers that multiply to be negative 24 and add to be negative 10. And so I go to 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Since it makes a negative 24, it means the signs are different. Since we want a negative 10, it means that my big side is negative. So therefore my small side is positive. And the ones that make negative 10 here are, excuse me, 2 and negative 12. So what I do now is, again, I don't go all the way out here. I focus only on this. Again, I'm ignoring that and focusing only on the part that I'm factoring here. And I do the same thing I did yesterday. Now we put 3x over 2, and we put 3x over negative 12. 3 over 2 I don't think reduces. As we see, it doesn't, so it stays the same. 3x over negative 12. So 3 divided by 12 turns into 1/4. So that'll be 1x over negative 4 again, because that negative is down there. And then in the end, again, here's my factors, but here's the number I took out. We have to put that number back in here when we go to work this out. And as long as we do that, we should be okay. Again, notice once you take the number out, you pretty much do the same thing you did yesterday, but you have to just check to see if there's anything that goes into it. Most of these that you're looking at are going to have numbers that are like 2, 3, 5, and 7 on the inside, but you just never know whenever you actually work out the other stuff. So again, just make sure that you inspect each of the problems that you face today. Again, it is important that you do not overlook the GCF because that is the most tricky part of the process. And just keep in mind, whenever you're doing your multiplies to equal and adds to make something else, if the numbers get really large, then there's probably something that can be taken out. They usually won't have you factoring something that multiplies to be 2,560 because that's really a big number. So other than that, like I said, get as much as you can done today. Make sure you have your notes done first, and then that way, whenever you finish your Math Excel, I can put points on your grade for your progress report today. Good luck.